Okay, so we continue from here. Again, let me show you the database. It's got these numbers in them, and those were obtained after we issued this command. So we are done with C in CRUD, right? We've created the database, and it was in 3 steps. We created the database first, then we created database table inside the database, then we inserted data into the database table, and we visualized those. And now we move on. Time is just from 1 to 24, right? So we do 24 plus 1 because df length is 24, right on line 16. Di was given in percentage per year. We're going to convert it to percentage per month. And you do that by dividing by 12. We have done this before, right? When we had to convert from percentage per year to percentage per day, we divided by 365. Here we're working with monthly, so we divide by 12. We want to implement the hyperbolic and exponential decline models, which you all are familiar with. So if b is 0, you have exponential. So here I'm testing if b is greater than 0. So it's going to be hyperbolic, and this is your hyperbolic decline equation for flow rate, for cumulative production. Only change is to multiply by 30.4375. How did we get 30.4375? I already explained that before, right? Number of days in a year. 1 in 4 years, you have a leap year, so we divide that by that 1 day by 4 to get 0.125. So 365.125 divided by 12. The average number of months, the average number of days in a month of the year is this. And now this rate that would have been in barrels of oil per day is now in barrels of oil per month, because that's the way the flow rate came in the Excel sheet I showed earlier. We'll do the same thing for cumulative production. These will give you the cumulative production in days, then we'll multiply it by 30.4375. We don't use Q in this equation, it doesn't show up. QI shows up, but QI is in percentage per day. So everything here will be in percentage per day, and you only need to change that to, sorry, it will be in barrels per day, because time is in months. So we convert it back, and this is now just cumulative barrels. Same deal for exponential decline, but we don't convert it yet because Q shows up in the equation for NP. So we first calculate in barrels of oil per day, then use that to get your rates, your Q. Multiply your Q by that just like you did here. So your Q is fine now. Then now we scale the flow rate by 30.4375. So now it's in monthly oil rates, so barrels of oil per month. This barrels of oil per day, and this is barrels, just like that. So we've put in this if statement to be able to switch between hyperbolic and exponential decline models, and these are just the equations you guys have been programming over and over again. So right now your rates data frame contains well ID, time, rates, and Q. I want to add 2 more columns. Q, rates from my model, one of these two. Q, which is NP from one of these two. So the original data here is your observed data. This is a decline curve model fit to the data. And we already calculated it from either of these or these, depending on what B was. And what's B for this case is 1.6. So you're here. It's going to use these 2 equations. So when we run this, Q is not defined because I didn't run this, right? You got to run all the way from T. The last one I ran was commit. So I stopped here. So we go from 43 down to 59. And now Q and NP exist and has been stored in here. And if you look at rate data frame, it's added those two at the back end, right? Q model and Q model. You can double click it to see it. Yeah, and they look okay, right? It's close enough to this. This is also close enough to this. So that's your model, well calculated. Another way to put data into a database, one was insert into, right? That was to put data into a database. But typically we use this when we have single values, like single values for each of these. If you have like an entire data frame, which is what we have right now in rates data frame, this is an entire data frame. It's going to be too cumbersome and messy trying to grab each item one after the other from here. We want to just copy all of the content of this data frame and pour it into the database. And to do that, there is a function from pandas, which is toSQL. Remember, we are talking about toCSV to store into a CSV file. Well, there is toSQL. So data frame name dot toSQL and the database table. So all of the data in rates data frame, I want to put it into a database table, a new one called rates. It didn't exist before. I'm going to create it and pour all of the content of this into it. Connector, which is the cursor, right? At the beginning. So if exists, meaning if this database table already exists, just append what I have here to the database. And you will see this comes in handy when you have more than one well. So when we start to do well 2, it's going to put the data for well 2 underneath that for well 1. And that's why you need to set it to append. There is also the possibility of overriding it, but we're not going to do that. Index equals false. It's not going to copy this first column, which is not part of your data. It's just pandas' index. So when you say index equals false, it's not going to copy this. So before running it, I'll show you the database and refresh the database again. There is only one table in it, right? Table 1. And this is the content of the table. So this is a new table, right? And it's going to be created after we run it. So Control Enter. We've created it. And we've put in all the data in the data frame into it. How do I know? Can I prove that? Yes. I refresh. Now it shows up rates. It even shows you the database command you used to create it, or the SQL command you used to create it. And those are the fields of your data. The fields are columns, right? So if I come back here, I can select the second table and you see all of the data. So tables in your database can be seen here, and you can switch from one to the other. And the important thing is your data is in here now. And all of this is just calculation of errors, which is not really relevant to this course. But yeah, I show you how to calculate error. Error is just the value, so we convert it to a NumPy array, right? The rate is the original data, the Q is my model, which I just calculated here. Find the difference, that's your error. And getting the sum of square error is the same thing as doing the transpose of the error multiplied by the error, which means squaring each item in the error and adding them all together. This is a simple and fast way to do it using NumPy's dot product. I'm not going to test you on this, but I give it to you free. So That's how you get error, and we can look at the error, but I'm not going to talk much about that. We move on to now retrieving information from the database, right? Remember CRUD, C for create, R for read. So we want to read from the database. And sure enough, there is a read underscore SQL query function that is available from pandas. And you do select everything, which is star. Star means everything. Select everything from what table? The rates table. Then the condition where well ID equals 1. All the data we have in there so far only has well ID equals 1. So that's the only option we have right now. And you always need to provide the second argument, which is the connector. Can do the same thing for the DCA, the decline curve parameters. So the second table, basically. Same function, pandas.read underscore SQL query, select everything from DCA params. And if you do that, it's just going to grab everything in there because you asked for everything and put it into those two data frames. And that's what we get here. Let's pro df everything. And the other one is DCA data frame, everything. Do we have to always get everything? No. How do you choose what you want? Exactly how I showed in the examples and here, right? Select what you want, the fields, which are the column headings. So in the same vein, you can come here. What are the data sets available? Rate scheme. Okay, what if I want just rate and time? Because I need to know what time corresponds to what rate. So I can ask for time and rate. So instead of selecting all, I can say select time, comma, rate. So it's going to give me both and not everything. And I run that and I get just those two columns. Of course, this is just pandas index. So that's how you use your SQL queries and all. And finally, when we're done, we can close the connection. And I'm going to stop the video before it gets too big.